Hello guys and girls, so as you know this video goes with the additional practice assignments. So I'm just going to take you through some of the problems, make some of the answers kind of maybe hopefully more clear. So when you have an equation like this is problem 1, it's good to simplify everything on the left hand side and everything in that right hand side expression before you start worrying about subtracting terms from both sides or adding terms to both sides. So that's what I'm going to do. I'm going to set about just starting to simplify things. So I'm going to distribute that 3 to both sides on the left hand side. So I did 3 times x and 3 times -2, making it -6. But I'm still not simplified on the left-hand side because I have 2 constants. I've got the 9 and the -6. So 9 minus 6 is 3. So 3 plus 3x now equals 6x plus 12. All right, so now it's a matter of preference. We could, if we want our variables on the left, I would subtract 3 from both sides, or 3 from both sides, just so 3x would be by itself. So that's what I'm going to do. You could have also subtracted 6x from both sides first. Doesn't really matter. So now I'm going to have 3x on the left and 6x plus 9 on the right. And now what I want to do is get all my x's on the left and all my constants on the right. So I don't have any more constants over on the left, just right here. So I'm going to go ahead and subtract 6x from both sides, so that they'll go to 0 here on the right, and I'll just be left with 9. But on the left, 3x minus 6x is -3x. So now I'm almost done. But a common point of confusion, so this is a mistake that I'm about to make. A lot of students want to do this because they think, oh, okay, well, the opposite of multiplication is division, and perhaps the opposite of -3 is +3. Well, that's actually right. I mean, the opposite of -3 is +3 in certain terms, but we're not necessarily going for the opposite. We're going for the inverse operation. And so the inverse operation of multiplication is division, period. And so we have to divide by the same number. Up here, when I was subtracting 3 from both sides, what I was doing is I was doing the inverse operation of this +3. And by default, that makes it -3, right? So we subtracted 3 from both sides. But down here, the inverse operation is just division. Plus, you can think about it like this. You want the coefficient of x right here. You want that coefficient to become 1, right? Well, -3 divided by +3 would make the coefficient -1. So we have to divide by the same number to get the right coefficient of +1. So now we end up with x equaling -3. And then if you were to check it, I don't have enough room on the slide, but remember, I expect you guys to check it, and that's how it was on the answer key. It comes out correctly. All right, I'll do a few more with you real quick. So this is problem 1b, and you'll notice that there's a fraction right here in the front, 7/4. And we can treat this equation just like the last one. It wouldn't be a big deal, but sometimes it's easier to get rid of fractions. Before I do my fraction busting, so to speak, that's a strategy we discussed in class, I'm going to go ahead and simplify make sure that the right-hand side is simplified. There's no fractions over here on the right-hand side. There's definitely some simplification. So I'm just going to rewrite the left-hand side. Knowing that I'm going to have to multiply everything by 4, it's going to make it easier if I just simplify this out. So I distributed the 2, so 2 times 4 got me 8, and 2 times m got me 2m. So I'm going to further simplify the right-hand side, and I'm going to end up with 8 minus 5, so 3 plus 2m. Okay, now that that side was simplified, there were no fractions on that side, I'm going to go ahead and bust out the fraction. So the lowest common denominator of the 4 here is 4 because there's no other fractions, right? So I'm going to multiply everything by, whoops, that's a sloppy 4. Multiply everything by 4. And when I do that, 4 times 7/4, look what happens. I'll do it over here on the right. 4 times 7/4, see if I can write that correctly, not 7 times 7/4, but 4 times 7/4. The 4's cancel out. That's the reason why you do the lowest common denominator. So they've canceled each other out, and you're just left with 7. So this is going to become 7m minus 8 equals, don't forget the right-hand side, 12 plus 8m. So now I need to go about solving this equation just like I would, any other equation. So I'm going to add 8 to both sides. So 7m equals 20 plus 8m. So now I'm going to want to subtract 8m from both sides. Remember, I'm trying to get the m's by itself on the left and all the constants on the right. So now I have negative m on the left equals 20. So if I divide by the, first you should realize that the negative m, there's really a coefficient of negative 1 there. So let me take this right here. So negative 1m equaling 20. If I divide both sides by negative 1, then I'm going to get positive m, right? Because these go to a positive 1. So m equals negative 20. Oops, let me try and write that better. M equals negative 20. And if you were to plug that in, it would come out correct. So there was 1b. I'm going to do a few more here on this video if you're interested. So I thought this was an interesting problem, 1c, because up until now, I don't know how often you guys have seen something like this. This term here in the front is a little different. So I'll just explain something really quick if you're watching this, that I'm going to take just this term for an explanation really quick. Just that term. So w plus 2 over 6 could be written as w over 6 plus 2/6. Because when you have a common denominator and you're adding or subtracting, you just add or subtract the numerators, right? Because the denominator is the same. So we can take this spread out version and combine it into this combined version, right? So why am I telling you that? Well, number one, it's something that you should know. But number two, when we go to get rid of the denominators, remember how I said we're going to multiply every term by the lowest common denominator? Well, in this case, we have a denominator of 3 and a denominator of 6. And this denominator of 6 applies to both the w and the 2. So all we still have to do, so I said all that to say, all we still have to do is look at our two denominators and find the lowest common one. In this case, it's obviously 6. But when we multiply this big term by 6, here's where I want to make sure this makes sense. Oops, sorry, I need my parentheses over here. When we multiply this big term by 6, we really sort of treat it just how we would treat anything else. So it's going to be, I'll do it over here on the right-hand side in maybe like this red color or pink color. So 6 times w plus 2 over 6, and I would go 6 over 1. Notice that we can still cancel out the 6's. Just treat this up here like one number. It's just a number plus 2, right? So this 6 goes to 1, this 6 goes to 1. So we're left with just w plus 2. That's essentially what I'm trying to say. So these guys cancel each other out, right? So w plus 2 equals, and then we have to think, okay, what's 6 times 2/3, right? Well, in this case, they don't cancel out totally. The 6 goes to 2, and the 3 goes to 1. So what's 2 times 2? Well, it's 4. So equals 4. So now we have ourselves a really easy equation to solve. We just subtract 2 from both sides and we're done. But the hard part here isn't necessarily doing it. I mean, it's easy for me to tell you, hey, multiply everything by the lowest common denominator, but understanding why that's getting you whole numbers. It's getting you whole numbers because by definition, if you multiply by the lowest common denominator, it's going to be a multiple of all the denominators, and therefore you're going to end up with whole numbers for your answers when you multiply. So let's finish this off really quick. So w equals 2. And if you plug that in, it works. All right, guys. I think, since this is not a mandatory video, I think I'm going to let it go long and just do a few of the other problems. So skip around until you see the one that didn't make sense to you. I'll go ahead and do D, E, and F real quick. All right, so here we go, 1D. It's very similar to the last problem. So we've got, fractions, obviously, and we want to take care of that. So let's multiply everything by the lowest common denominator of 4 and 12, which is 12. So 12 times z plus 5 over 12 equals 3/4, right? So when I go 12 times this term right here, these 12s are going to cancel out. So I'm going to end up with just z plus 5 equals. And then just for the sake of example, when I do 12 times a 3/4, again, the 12 and the 4 are going to cancel. So we're going to have 3 4s up here and 1 4 down here. And 3 times 3 is 9. So at this point, it's a quite, I guess it's become quite easy. So subtract 5 from both sides and you're basically done. Z equals 4. All right, E and F coming. All right, so you notice this problem's a little bit different because there's a bunch of different fractions, but the concept is the same. We're going to multiply every term in the equation by the lowest common denominator of the terms, right? Well, just so happens, I believe the lowest common denominator of 4, 5, and 10 is 20. So we're going to multiply everything by 20. And I just want to point something out. I could combine these terms before I did that. I could find a common denominator of 4 and 520 and actually do the subtraction and have one x term. But I'm thinking, why do that if I don't have to? So if I just have to multiply everything by 20 to get rid of all these fractions, I'm going to take that route because it's, for me at least, it's the easiest route. And I like to take the easiest route, I'll be honest with you. So I wrote 12, but I meant to write 20. You'll have to forgive me. So that's 20. Okay, so now I'm going to try and tell you how I'm doing this in my head. And you probably already can do it in your head faster than me, but just in case. So 20 times 3/4. I know right off the bat, this is how I think about it. I think, okay, how many 4s are going to fit into 20? Well, there's 5, and so then 5 times 3 is 15. So I know this term's going to become 15x. And just to show you why that works, remember 20 times 3/4. Well, that's the same thing as 20 times 3 all over 4, right? 4 times 1 is just 4. So what I'll do sometimes, I'll just do that part of the division. So I'll go, okay, what's 20 divided by 4? Oh, that's 5, so 5 times 3 is 15. Because if you look at it, they cancel out in that way, right? So there's 1 4 here, there's 5 4s here, 5 times 3 is 15. So it works, and it's faster. And actually, it's not full of error. It's actually pretty, if you're thinking about it the right way, it actually is pretty accurate. So 20 times 3/5 is going to be negative 12 because it's a negative 3/5. Whoops, let me change back to white here. So negative 12x. And then, of course, we'll get negative 14 and 40. Okay, now I can start simplifying. So this is going to be 3x minus 14 equals 40. Add 14 to both sides, as you guys know. And we'll get 3x equals 54. Divide by 3. X, oh gosh, what does x equal? Now I have to think 18, right? Okay, so x must equal 18. And if you check it, it comes out. Okay, the last problem coming up. So this is the last problem I asked you guys to do, and part of the reason I put it in the assignment is because of this negative 2 right here. I want to make sure you guys are really good at distributing negative numbers and that you haven't forgotten what we did in the last unit. So it's a negative 2 being distributed. So 8g, by the way, I'm simplifying the left-hand side expression. So 8g, and then a negative 2 times g, so that's going to be a negative 2g. And then a negative 2 times negative 4 in my distribution makes a positive 8, right? So that's going to equal 11g plus 28 still. I can simplify the left, so I'm going to get 6g plus 8 equals 11g plus 28. And then I'm subtracting 8 from both sides. At this point, I'm not explaining every step because I think you guys have got this by now, these little steps. Okay, now at this point, I do know that some of us start to get, like what should I do? Well, we want all the g's on the left, so I'm going to subtract 11g from both sides so that they'll go out to 0 on the right. So 11 take away 11 is 0, right? So we're left with just 20 on the right-hand side, but 6 minus 11 is negative 5g. So now I divide by negative 5, not by 5. That's important. And g comes out to negative 4. All right, guys, those are the problems and the examples. I hope you found this helpful if you needed it. And all right, let's study hard and let's do well on our unit test. I know you guys will do great.